Hello and welcome to another lecture on differentiation. Today we shall be discussing about mean value theorems that include Rolle's theorem and Lagrange's theorem. Later we are going to deal up with some numerical problems that would be based on verifying the Rolle's theorem or the Lagrange's theorem for the given function. So now starting with the mean value theorems, which include Rolle's theorems and Lagrange's theorem. So now starting with discussion of Rolle's theorem, which states that if a function, let's say fx, is derivable in the interval ab and fa is equal to fb, then there exists at least one value of x, let us see, within the interval ab such that the derivative of function fx at point C is equal to 0. After the statement for Rolle's theorem, we come to geographical interpretation of Rolle's theorem. For that, let us consider A and B be the points on the curve y equal to fx corresponding to real numbers a and b respectively. Now here, since fx is continuous in interval ab, the graph of the curve y equal to fx is continuous from a to b. Also, fa is equal to fb. The coordinates of the points a and b are equal, that is m a is equal to n b. Then Rolle's theorem asserts that there is at least one point lying between A and B such that the tangent at which is parallel to the x-axis, that is, there exists at least one real number c in interval a b such that f dash c is equal to 0. There may exist more than one point between A and B, the tangents at which are parallel to x-axis, that is, there exists more than one real number between the interval a b which is equal to c such that f dash c is equal to 0. Next we are going to consider Lagrange's theorem, which states that if a function fx is derivable in the interval ab, then there exists at least one value of x which is c lying within interval ab such that fb minus fa whole divided by b minus a is equal to f dash c. Next we are going to consider geometric interpretation of the Lagrange's theorem. For this, let a, b be the points of the curve y equal to fx corresponding to real numbers a, b respectively. Now since fx is continuous in interval ab, the graph of the curve y equal to fx is continuous from a to b. Now again, as the function fx is derivable in interval ab, the curve which is equal to fx has a tangent at each point between a and b. Also, as a is not equal to b, the slope of the chord AB exists and its slope is equal to fb minus fa whole divided by b minus a. Then Lagrange's mean theorem asserts that there is at least one point lying between a and b such that the tangent at which is parallel to chord a b. There may exist more than one point between a and b, the tangents at which is parallel to chord a b. Lagrange's mean value theorem ensures the existence of at least one real number c in interval a b such that f dash c is equal to fb minus fa whole divided by b minus c. Next we are going to discuss certain problems that would be based on verifying the Lagrange's mean theorem and the Rolle's theorem for the given function in the given interval. Now we require to verify Rolle's theorem for the following function, which is equal to x square plus x minus 6 in the interval -3 to 2. Now here we have the function fx, which is equal to x square plus x minus 6. Now we have to verify the Rolle's theorem for this polynomial function. Now let's label this equation as equation number 1. Now in order to verify Rolle's theorem, we know that it has to satisfy three conditions. The first one is that the given function must be continuous in the given interval. Now here, since fx is equal to x square plus x minus 6, which is a polynomial function, therefore it is continuous in interval -3 to 2. The next condition is that the function should be derivable in the given interval. Now here, since fx is a polynomial function, it is derivable in the interval -3 to 2. The third condition is that fb should be equal to fa. Thus here we are required to evaluate the value of f2 and f of -3. Here f minus 3 is equal to -3 square -3 minus 6, which is equal to 0. Thus the value of f minus 3 is equal to 0. Next we are going to evaluate the value of f2, which is equal to 2 square plus 2 minus 6, which is also equal to 0. Now since here the value of f minus 3 is equal to the value of f2, therefore all the three conditions of Rolle's theorem are satisfied, and therefore there exists at least one real number c in the given interval -3 to 2, such that f dash c is equal to 0. Now next we are going to differentiate equation number 1 with respect to x, and thus we have the derivative of fx as f dash x, which is equal to 2x plus 1. Now f dash c is equal to 0. This implies that 2c plus 1 is equal to 0. This gives us a value of c equal to -1 by 2. So there exists -1 by 2 that belongs to interval -3 to 2, such that f dash c, that is f dash of -1 by 2, is equal to 0. Hence the Rolle's theorem is verified for the given function in the given interval. Next we have to verify the Lagrange's mean value theorem for the given function and find the value of c, where function is equal to 3x square minus 5x plus 6 in interval 2, 5. Here we have the function fx equal to 3x square minus 5x plus 6, which has been labeled as equation number 1. Now we know that there are two conditions of Lagrange's mean value theorem that are to be satisfied by the given function. The first condition is the continuity of the given function in the given interval. Now here fx, being a polynomial function, is continuous in interval 2 to 5. The second condition checks the derivability of the given function in the given interval. Thus here fx, being a polynomial function, is derivable in the interval 2 to 5. Thus both the conditions of Lagrange's mean value theorem are satisfied. Therefore there exists at least one real number c in interval 2 to 5, such that f dash c is equal to fb minus fa divided by b minus a. Now here b is equal to 5 and a is equal to 2. Thus f dash c is equal to f5 minus f2 whole divided by 5 minus 2, where f5 is evaluated as 3 into 5 square minus 5 into 5 plus 6, which is equal to 51. Next we are going to evaluate the value of f2, that is obtained by substituting the value of x equal to 2 in equation number 1. Thus f2 can be written as 3 into 2 square minus 5 into 2 plus 6, which is equal to 3. Next, differentiating equation number 1 with respect to x, we have f dash x equal to 6x minus 5. This implies f dash c is equal to 6c minus 5. Therefore, f dash c, which is equal to f5 minus f2 whole divided by 5 minus 2, can be rewritten as 6c minus 5 equal to 51 minus 3 divided by 5 minus 3. This gives us 6c minus 5 equal to 16, or c is equal to 7 by 2. Thus, there exists c equal to 7 by 2 in interval 2 to 5 such that f dash 7 by 2 is equal to f5 minus f2 whole divided by 5 minus 2. Hence, Lagrange's mean value theorem is verified and c is equal to 7 by 2. With this we conclude this lecture, which was based on the Lagrange's theorem and the Rolle's theorem.